Hi there, I'm your host Clive Serkin, and welcome to the Unstuck podcast, where we're on a journey to help you get control of your work environment, get yourself unstuck, and perform to your full potential. So my guest today is the wonderful Wes Chaar. Wes is currently the Chief Data and Analytics Officer at Fyllo. And he's also, by the way, and we'll get into this later on, the winner of an Emmy Award for engineering and technology. And I've never heard of someone winning an Emmy Award for engineering and technology, but we're going to find out about it. So, Wes, welcome. It's fantastic to have you on.
Well, I'm glad to be here. Good to talk to you, Clive, today.
It's I met you recently. I'm saying the last year or so, but I was aware of you because we run around in similar circles. But your story is an interesting one, and the team always refer to you as Wes is the guy who his career started in NASA and now he's in the cannabis space. And so I want to talk about that journey because it's literally that is the journey. As I understand it, you have a PhD in aeronautics. You actually worked at NASA or on the NASA Jet Propulsion Program, and that was your area of expertise for your PhD from UT Austin. And then you moved along in a career that saw you at Sabre and Delta and Sabre again, and then Turner, where I believe that's where you won the Emmy Award, and Catalina. And now you find yourself at Fyllo. And, by any measure, that's an incredibly interesting journey that is probably atypical on the surface of it. So talk about your career and why you made those choices, because I think it's always instructive when you get underneath the covers and get a sense of the logic behind the choices people make.
Yeah.
So start anywhere you want, because there's a lot to cover there.
Yeah. Well, thank you, Clive. So like you said, actually my bachelor's in computer engineering and master's in computer science, and my PhD, like you said, is from University of Texas at Austin, where I get the degree in aerospace engineering. But when you do aerospace engineering, you have to select what is it that you're doing in aerospace, not to go through every discipline possible to specialize in, but one in particular that I was always interested in is navigation at space. So there is basically a specialization called GNC, which stands for Guidance, Navigation, and Control. So I didn't work for NASA directly, but I worked for Center for Space Research, which was in Austin, Texas, which was a subcontractor for Jet Propulsion Lab. Jet Propulsion Lab, which used to grant money to basically solve this problem and that problem. And one of the problems that I worked for them was really the problem of interplanetary navigation, how you travel between planets. In particular, I researched for them, new algorithms on how to travel to Mars in different ways basically where mathematical algorithms are learning from mathematical algorithms in space to create new mathematical algorithms. This is before people start talking about, AI and machine learning and using machine learning so that these algorithms can learn online and evolution, correct, of algorithms, which was very unique. And it's something that was tested in parallel to their traditional navigation technique for the Mars Pathfinder mission, which landed on Mars on July 4th, 1997. So I was basically living in the navigation and interplanetary navigation world, and love the mathematics that I did. But I always followed the airline industry. Always was very interested in the airline industry and what they have done. Reading about how they introduce data, correct, to develop revenue management, which is basically how you manage your inventory and you sell it to which consumer at which time, at which price, etc. How they really design crew scheduling and flight scheduling algorithms, etc. So when Sabre, what used to be part of American Airlines, they were starting a research group in the late 1996. At the time, email was just starting. Basically, I reach out to them, said, "Hey, I have an idea, whatever." They flew me. Within a couple of days, I pitched the ideas on how we can use those algorithms from aerospace to do better revenue management was the initial pitch, and how you can blah, blah, blah. And actually they were like taken, like, wow, this is really interesting, and got an offer actually the next day from Sabre, which was part of American Airlines, as I said, and moved from aerospace to airlines. And I really never looked back. I mean, it was a great decision. The problems are very intriguing, business problems. And that evolution continued, correct? It continued from the airline space, like you said, from Sabre slash American to Delta Airlines, and then, back to Sabre for a brief period until I got a call from Turner Time Warner, where in 2008, their CTO invited me to come over, listen to what they have done in terms of technology. A very, very, very smart guy that used to be way back when at University of Chicago. His name is Scott Teisler, and I knew what Scott wanted to do. Him and Jack and a few other people at Turner, they wanted to basically make ad decisions and marketing decision and media decisions based on data. Use this data that they have collected, correct? And this incredible technology platform that they invested in for a long time to really do things in a data-driven way and really enable the company to have smart decision support system. And from Turner Time Warner, after 10 years, I spent there 10 years. But back to the Emmy, which you mentioned, yes, I didn't even know, none of us knew that there was an Emmy in engineering and technology until somehow someone pointed this out to us. And it was not Wes Chaar alone, it was teamwork. So it was the technology team, the analytics team, which I led. It's all of us coming together. But within that engineering, that system, that ad tracking system, which won the awards, it used to be called Crossroad. Within that, there were a lot of forecasting and optimization algorithm that my team and I have developed, and that's how the Emmy came in engineering and technology, which I think we won it in 15 or 16. I can't remember now,
But
but that was me. Yeah.
There's a pattern here, at least to my eyes, which is yours is a career where you've been on the forefront of innovation as it relates to data science and data analytics. If you think about it, I mean, I know you and I have talked about, your work when you were working on the NASA program with genetic algorithms, but there seems to me a pattern that what draws you, aside from, I would assume, people, is problems that are on the forefront or on the cutting edge or truly innovative in whatever category you're in. Is that a fair assessment?
That
Is
is a
that
fair
what drives
assessment.
Wes?
That is a fair assessment, because when I went to Sabre, it was, I think I have an idea of how we can do it better. You can do it better. We can do it better together. And it was something that I proven. And, we can talk in details about what I've done. But with Turner Time Warner, it was a clean slate. I was like, wow, there's so much innovation here can happen. And I was given, in some sense, uh, the carte blanche to go hire what I need to hire to prove the concept initially, to the sales organization and to the business. And, it is documented that my team over 10 years, not 1 year, 10 years, have generated cumulatively $1 billion in additional revenue for Turner Time Warner. This is how innovative the team was and the incredible things we've done. And, from there, I moved to Catalina when Berkshire bought Catalina. I guess the Berkshire board, one of the board members at the time, was leading the search, and they recruited me also to help the company in its digital transformation, because it was a company at the time that was seeking to become a player in the digital space and in the ad tech space. And, after 3.5 years leading US, Europe, and Japan, I got connected, out of the blue, with Chad, our CEO. And I heard again, it was again a space where, we can be innovative. It's going to be groundbreaking. And of course, it drew me, like you said. Yes, it is true. Your description is accurate.
And then, you talk about the value creation, in Turner as one example, but I know for a fact, if you go back to all of them, there's value creation in a substantive way for all of them. It's easy in retrospect to look back and say, look at the value we created. But at the time, I would imagine what you were pitching was new to the category, new to the market, at
Oh,
times
oh,
somewhat esoteric. And I would imagine tough to drive change and buy-in. Is that
yeah,
fair, or was it uneven? I mean, I'm curious about how you engage the decision makers, the business, to get
sure.
them to buy into something that is not, that they don't. I would imagine the vast majority of the people don't fully comprehend at a level that data scientists are working at, and so it's hard to convince them to come for the ride and trust.
Yeah. So a couple of notes. In the Sabre slash American Airlines days, they were already very familiar with data and with algorithms and the value of using algorithmic way to run an airline. So it was different over there. I didn't have to convince anyone. The company was already established in that, and the reason they were established in that because the industry got deregulated years before that, and then they had to figure out a way, correct, how to run an airline in a deregulated environment, and they figured out data and algorithms and writing all these forecasting and optimization made us basically thrive in a deregulated industry. Now, when I went to Turner Time Warner, you are so correct. I remember Scott telling me, you're going to have, your work cut out for you with the business. So the first thing I've done, I remember, going up to New York and going to the Time Warner Center and talking to folks. Some of them thought me, I don't know, maybe like a green monster, was, walking around, whatever, talking to them about that. But very quickly, I partnered with one leading person in the sales organization who had a couple of pain points, correct? And I said, well, let data science show you how this is actually could be done in a much more efficient way. Just give us a chance and blah, blah, blah. Something that used to take them, I don't know, 15 people to do over 2 weeks, was done in, I don't know, 10 seconds using an algorithm. And then they realize, oh my God, the productivity and attaining. And then this discussion started becoming, from others, well, who solved this? How did it get solved? And then people came to the table. Well, we want to talk about this. We want to talk about that. So the lady was the head of strategic planning. Her name is Nicole Slavin, a good friend of mine. We became very good friends over the years. Nicole was key, correct, to say, you know what, this is really, I see now what you're saying. We have a lot of problems. We understand we starting to understand what you're trying to do. And that opened the door to a variety of projects. So we were not an unknown quantity after we proved that first project. It was just myself, actually, initially, and eventually one more person, but eventually built up a team of 35 top-notch data scientists that really all the stuff. But you're right, you have to find a buy-in from the sales organization. Never got geeky on them. It's really about, the value proposition and how things get solved and how you're really attaining the best possible solution and how you're taking, correct, your analysts and the staff to do much more interesting things, correct, rather than things that can really be automated and provide the value. The second project that we've done was, automating ad scheduling. If you think of TV, people worked off of log files and they put the ads in a manual way where they should show up. And, obviously when you're inputting two campaigns at a time, and then you have all these campaigns eventually conflicting with each other, it's just a manual process. But if you introduce algorithm, which I did at the time, to basically look holistically at all the campaigns. And typically, Turner Time Warner will have 8,000 campaigns easy running at any point in time. 8,000 campaigns on all their networks at any point in time. How are you going to manage 8,000 campaigns? An algorithm can do that. An algorithm can predict where the audiences are going to show up. A good algorithm, at least, correct, with a fairly good accuracy. Not every forecast. Obviously, forecasters are not 100% accurate. The question is how wrong they are. Hopefully, they're very little wrong. And then from there, you start making the decision on how you allocate inventory, optimize. That project at the time saved, units in values of tens of millions of dollars. So let me explain what I mean saved units. Because, Clive, when you don't deliver on a campaign, if you think of TV, then you have to give the advertisers more units, correct, to meet what is it that you promise in terms of delivery. So if you're suddenly, now managing all these thousands of campaigns and you're minimizing that liability by tens of millions, you have now more inventory to sell in the marketplace. So that one project, opened the eyes on top of the first one. Oh my God, we can do a lot of things, and there was really never looking back after the first two. At Catalina, I had the backing of my manager and then the CEO and then the board, the initial board, the Berkshire board. So it was all good. And at Fyllo, I have to say, with what Chad, and what really made me take the job is Chad, and having the conversation with our CEO, Chad Bronstein. And I knew, we can do the same thing. So he has the vision. He knows what we can do with the company, and he's very supportive. And actually, for that matter, the whole company is very supportive. So, yeah, you're right. But first, you have to find an ally on the business side. You don't solve problems in vacuum if you're not going to be able to implement them. And one of the things that you always hear, probably, Clive, is that we have these data scientists, we build something, but it never gets implemented for whatever reason. You really need to be, how do you say, very close to the business and really addressing the problems they care about. It doesn't mean that you cannot put on the table new ideas and new thoughts, but you really need those business partners.
Right.
And I've been able to do that. So
So,
having the business partners is key.
well, that's, and I'm glad you say that because I think that's crucial. Is if you're applying the complexity of the work you do in service of a fundamental business proposition, all of a sudden you become relevant, credible, and central. And from there, you can, off of that base, then build, from there. But I'm going to ask a question which is arguably potentially a dumb question to ask because it's so broad in its conceit. But you know, if you look at your career, you went from data as a nascent kind of thing in very, very specialized areas to now, I think it's safe to say that data and data strategy, and mastery over data in service of your business is at the heart of any business. It's hard for me to imagine any business that what I just said isn't true and holds credibility to. But at the same time, and I speak to many people from both, small startups to scale Fortune 100s, and many of them find it overwhelming, and on two levels. So, larger scale companies, it's sort of overwhelming because the world is so large, and it's like, where do you begin? And equally, we have so many things going on, but none of them are connected. On the other hand, in smaller startups, pre-revenue, Series D growth, doesn't matter where you are, is you're highly resource constrained, and data strategy and building capability, um, you know, requires substantial resource. So I know that what I'm asking is, how long is a piece of string? But in this world that we find ourselves in now, what counsel would you give people as they think about gaining mastery over data in service of their business? Um, in pick anything, but massive territory to cover. Where do I begin? Ever changing regulatory landscape, and I don't know where it's going to go and what's going to happen. Major players out there that control, walled gardens. Where would you advise? What would your counsel be to someone to go? Here's how I'd think about it.
Well, I mean, if I'm walking to a business and the question is, how do we get into data, or what is it that we do with data? The first thing, if I'm thinking of a business, any successful business, how do you say, does, one thing or few things really, really well, or they want to do one thing or very few things really, really well, correct? And if this is the case, then, what is it, the type of data, correct, that's going to enable me to, correct, be even smarter about running my business? So that's, that will be my initial focus. What are the type of data that I need to be collecting, and hopefully first party data, correct? Because of the ever changing, like you said, regulatory and various other things that are going on, correct? Not data that you license, preferably first party data. And what is it that I need to collect? Do I have it? Do I need to collect it? And what is this data we think, is going to deliver for us as a value? A company that is not going to invest in a data strategy, or in a, if you want to call it, a data driven organization using obviously algorithm, etc., and very smart techniques to really optimize their decision making, others will do it, other competitors will do it. And I've seen that, over, actually, there's, I can give you an example, where one airline went out of business just because the other one was doing this, and then that airline was not doing that. It's actually a very famous business use case. But going back, it has to be, how do you say, focus. You do not want to go in, we want everything and everything now. No. What are the things that we're really trying to dominate in? What type of data do we have or don't have? What do we need to collect? And how do we go about, harnessing this data, building a small data science team? But I think, once you get the first one, what I've seen with companies that haven't done that, example, Turner Time Warner at the time, initially at least, the how do you say, the momentum that you gain after, doing a couple of projects within the organization is, I mean, it's like we couldn't keep up, correct, with the requests and the things that need to be done. There was if you want to call it, a tidal change in the attitude of the company on the value of data science and what data science can do. So if I walk into a company, well, let me understand the things that you want to dominate in, that or that you think you're good at or want to be really good at and dominating in, and develop a data strategy around that with a very focused, output. We're collecting data because we want to do this, because we think we can, example, forecast better, we think we can optimize better, etc., etc. If you don't mind me, Clive, just to give you an example of companies who went into data and one that didn't. And I'm going to give you an example from the airline industry. You may remember at some point there was a low cost carrier called People Express. I
Yep.
don't know if you. Okay, well,
Yep.
People
My
Express went
first, by the way, my first flight in America was People Express.
well, People Express went out of business, correct?
Yep.
And and they were competing with American Airlines. And then when the company went out of business, my understanding, reading way back, is that their CEO said, you don't compete, in this day and age without revenue management systems, which are basically inventory systems driven by forecasting and optimization. And the reason they went out of business because they didn't get into the data business, correct? They went out of business because they get the data business. What the American was doing, they had data. They were looking at booking profiles. They knew when to hold inventory for the high paying business passenger, while People Express was filling up on cheap, consumers that couldn't even cover the cost of a low cost carrier.
Uh,
So eventually, no matter how low their cost was, they were filling on so cheap passenger, inventory, correct? That they're filling up the planes. Load factor of 100%, yeah, but the 100% with the cheapest ticket is very different, with a business traveler, maybe where you have a mix, correct, of consumers at different price points, where you really, filling up with a winning flight, correct, with the revenue making flight, with the profit
yep.
actually making flight. And that's how they went out of business, by not getting into the data world and thinking at the time that they can simply run it just by cutting costs. I mean, Southwest Airline today and all the other low cost carriers, they use revenue management systems.
Uh,
They know that. So no one runs
although,
on lowering costs alone.
although I have to say this, and so I'm going to give you a chance to defend yourself because, um, the topic of the day is the airline system. Is a disaster right now. And there are people who would say it's because of people like Wes who built these revenue management models that's killing the system, and I can't get on a goddamn flight. So tell me you're an insider. Tell me what's happening now. What's really going on? Because there isn't a day that I don't go without someone calling me and going, I'm stuck. I mean, my wife and my daughter spent 3 days in New York because they couldn't get on a flight because the system collapsed. That's not revenue management.
No, no, that's not revenue management. So what's happening is more an operational issue actually today. It has nothing to do with the algorithm driving inventory and inventory availability. No. So it is an operational problem, my understanding, due to lesser staff, or maybe, when you have crew, there is only so many hours that they can fly, correct? But depending on FAA rules and various other things. And I think during COVID, a lot of pilots and others have taken early retirement, correct? They took these
Yeah.
packages and they're out of the workforce. There is now, I think I heard something maybe in Congress to move the pilot retirement age from 65 to 67. So it's more an operational issue. It's not a they didn't get on the flight because the flight got canceled. Now there are cases sometimes where a flight gets overbooked. But typically the airlines have managed the inventory to make sure that the passengers get on the next flight. So it's not really the revenue management system or the algorithm that have driven the operational, how do you say, malfunctions today. It's more labor issues.
Okay, good. I just want to get the record straight
No,
so
no,
people
no, no. I'm,
so
I'm not
people don't
involved.
blame my friend Wes.
No, 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 no.
So let's talk about Fyllo. So you've had this extraordinary career, doing some really innovative stuff. And if we have some time later on, I do want to talk about genetic algorithms. Um, but let's talk about Fyllo. So Fyllo, um, is on the forefront of the cannabis category, but really, it's a company that's designed to help companies in hyper locally regulated industries, cannabis being one of them, crypto being another, gaming, local rentals,
Short-term
for
rental.
example. Um, and so it's blazing an entirely new path, an entirely new category, and it built on, it's a tech compliance platform, awash with data. Talk to me about the vision and how you see the opportunities to create value. for our constituents, for our customers, and we can, go anywhere you want. But it'd be good to talk about the CPG companies that are buying our data,
Yeah,
and the value that's getting created through that. But I mean, there's a lot of places you can take it, and we have plenty of time. Let's talk about
sure.
what's exciting you about Fyllo and the work you're doing there.
Well, the data is unique, correct? So it's not, typically easily accessible, correct? So it's unique data assets, whether it's crypto, short-term rentals, online gaming, or cannabis slash CBD. So what is so unique about this data is that, from looking at the data and using it and testing it, is that it over-indexed in a big way in many, many, many categories. So because you mentioned the CPG world, if you're walking into a client, correct, that used to sell a CPG client that used to sell a particular product, and they're seeing their market share declining, correct, because people are maybe using an ointment of some sort, a CBD ointment, correct, to deal with their pain or whatever it is, they will be interested, correct, in reaching out to those consumers, perhaps with a new product or new promotion, etc. So the uniqueness of these data assets is that they over-index in many categories. And if you think of return on ad spend, what you're seeing is as to actually that the Fyllo segments and the Fyllo audiences over deliver compared to others. And that's why you have so many thousands of brands that do business with Fyllo because they see the results, correct? They see the ROAS and then they see what's happening. Now, when you think of this data asset, audience and measurement, correct, is one aspect, correct? So this is the campaign. This is audience and measurements, which I know you're familiar very well, Clive, with. But what could you do with these data assets? If you take this data asset and enrich it with other data sources, you could launch, correct, a play in the DaaS world, DaaS data as a service world. If you enrich the data, which we have done here at Fyllo, you can launch a play for yourself in the TV ecosystem, correct? Potentially the addressable TV, some of the things we're looking at. So, if you think about, where Fyllo was, a year ago, we were in the audience and measurement business, but we enhanced that significantly with customs and various other capabilities. But also, we launched, in some sense, new plays in vertical space. So I'm talking DaaS is one, TV play in the ecosystem, and others that are going to be announced, in time. So, if you think about that, so you took a unique data asset, first maximized it in the audience space, and that was the first thing. But Clive, as you may know, when people say, "Oh, I have a data asset," oh, and if I throw on it machine learning, I can derive more of it. Well, no, I'm sorry. I mean, if you did the good modeling the first time around, whether it was machine learning or something else, yeah, maybe you throw an algorithm, you're going to get maybe an extra sliver. But to really take a data asset and, how do you say, dimensionalize its value again, you have to enrich it with other data assets. So that's why data enrichment processes, no matter how unique your data set is important to launch new lines of business. So this is some of the things that we're doing here internally. Not only using the most sophisticated and the most relevant algorithm that we can to drive value from the initial unique data asset, but also what do we enrich it with to, how do you say, unleash new verticals and new lines of business, correct? With the enriched data asset.
So, give me an example for the uninformed. Let's take me as the proxy. What do you mean by enriching a data asset?
So for example, if let's just say someone is buying a product, and I'm not talking necessarily about Fyllo, but in general, correct? Let's just say someone bought something at the grocery store, and some company, the retailer, or someone who licensed this data, what do they have? They have the name of the product, correct? And they may have the name and the barcode, and that's it. Okay, so maybe they bought Kellogg's cake, correct? But let's just say you, as an advertiser, are looking, perhaps for people that are not only cereal eaters, but you want to find out perhaps people that are looking for low sugar, correct, in their cereal. Simply buying, and knowing that it's Kellogg's cake only tells you it's, how do you say, it's someone who eats cereal. That's all, correct? So, but if you take now this data assets of all these UPC codes and the name of the products, and you enrich it with label insights. So what I mean by label insights, if you think of a box of cereal and all the information on it, how many calories, how many sugar, name, how it was a blah, blah, blah. If you enrich it with all of that, now when your advertisers comes to you and say, yes, I know you can create for me a serial buyer, but I'm looking for people who are interested in low sugar whatever because we're launching this new product. You couldn't do it the first time around, correct? It was more a spray and pray, correct, approach, because you're reaching to all the cereal buyers. Some may or may not be interested in the product. Versus when you start looking at the data, because of the enrichment process that you did, you can identify, correct, those segments, those audiences that are truly interested, correct? Not only because maybe they're buying other cereal with low sugar, but maybe because of other purchases, correct, that tell you that are always looking for low carbs and low sugar, and then you can reach out to them. So if you just had the initial data asset that you had, which was just, who bought what, not understanding the details of what they bought, you couldn't have created those audiences. This is an example of how data enrichment works. This is not a Fyllo example, but a general example to give why data enrichment is important. So another one is, well, do we know perhaps if they drink coffee, well, then you can enrich perhaps with geolocation data, correct, to answer that question, and etc. and etc. So that's why just having your initial data asset typically is not sufficient, always actually not sufficient. If you want to dimensionalize the business, if you just want to sell segments, I can only sell people who know cereal. I don't know anything what kind of cereal they like, what type of flavors they like, what type of ingredients they may not accept or not accept. I don't know anything about their lifestyle. Then you're going to limit, correct, what you could do with your data asset. And hence, enriching becomes really important to enable the things that I just described.
Got it. And then, so you brought it up, and we might as well cover it. And as we get close to the close, the aside from the metaverse, the most commonly used, overused, potentially concept, word, thought, action is machine learning and AI.
Uh-huh.
And no doubt, it's fundamental. But I tend to hear people just throw it out there. And we had talked earlier on about data and data science in service of a business problem. What's your perspective on how people should be thinking about machine learning and AI, so that they get the most out of it versus, what I often see is random acts of machine learning?
Exactly. So, the way I think of machine learning and AI, it's some of the tool set that you have in your box. Not everything needs machine learning. Unless people start calling sometimes linear regression machine learning, which is not true. Linear regression is just a basic mathematical technique. So the point is, in your toolbox of data science, you have your traditional mathematical modeling techniques, correct? And then you have machine learning that came along. And why did machine learning, became so exciting and so out there? It's not that machine learning did not exist in the 90s. It did exist in the 90s and even earlier. The reason it wasn't as how do you say as prevalent at the time, because it really works well with tons of data. So when the data explosion happened, correct, with internet data and social data and various other data sources, suddenly you have a huge amount of data where machine learning can come in and really be a quick way, correct, to model a few things and how do you say and solve these problems. But not everything needs machine learning, correct? Sometimes just a simple forecasting algorithm will do fine. I just need a linear regression. Now, the two things that I will caution about, that I see, if you don't mind me, saying what I think, things are probably heading maybe in my mind in machine learning
Yes,
and analytics,
please.
is that machine learning is a black box, correct? You're inputting the data, you're outputting, oh, wow, the accuracy, yes, we tested, we validated. I think an area that I'm very interested in and, I've been working on is what I'm calling explainable AI or explainable machine learning and AI. How do you take those results and actually put a story around it? Not a geeky story, but actually a business story on why things came up the way they came. Because, at the end of the day, you're working for businesses, correct? This is to drive business decisions. And, I think explainable AI or explainable machine learning is one area. The other thing, if you think of analytics, Clive, there was the, what is it, descriptive, hey, what happened, why it happened, correct? And then, predictive, descriptive, prescriptive, then why it happened, and then predictive, where, what's going to happen next, correct? You looked at the data and I understood what happened in the past. I'm going to develop forecasting algorithm and I'm going to develop optimization algorithm, correct? After that. So it was from descriptive to predictive to prescriptive, the optimization. The next thing is that I think will happen is more algorithm that can do a lot of things that us human can do, correct? So what I call in my mind, probably the next evolution of analytics, I call it personally, it's a Wes Chaar
You call it
mnemonic.
what? Say that
I,
again.
I call it cognitive analytics.
Got it.
Cognitive analytics will be the next thing. in the analytics space. But it's all around, correct, techniques that are very clever in mimicking really human intelligence and being as sophisticated and do really interesting things. But I hope I answered your question.
And no doubt about it. So we're out of time, but I have to push a little further because we got to talk about genetic algorithms. That has to be our close. So talk about this is back in your NASA days.
Yeah, back at Center for Space Research days. Yes. So the idea is that you want to send these spacecraft into space, and you have only so many engineers, correct, that NASA had. How could we create approaches, correct, to do navigation in an accurate way when you have less engineers and maybe less data and etc. And the data typically is collected from something called the DSS, the Deep Space Station, that are all around the globe, basically, that collect data from these spacecraft. So the more I thought about it at the time, it's like, okay, so we're going to make these decisions and we're going to put one algorithm. That's not going to work, one algorithm, because if things are changing and you don't have enough engineers to manage all these things, maybe the best thing to do is to have a pool of algorithms that are processing the data. But as their performance is evaluated, we do use genetic algorithms. So the Darwin theory, correct, of evolution. So I was like, so this is the idea. So you take basically every algorithm and you code its parameters in actually zeros and one genetic codes, actually. And then, I basically let algorithms, depending on a random process, to, how do you say, cross over and mutate. So you take suddenly two algorithms are getting together, they're creating a new algorithm by themselves. And that basically what when we tested this at the time, it only continued to create more and more accurate algorithm with the evolution, correct? Yep. Which is basically, the Darwin evolution. Basically, we took the whole idea of evolution into a genetic algorithm for algorithms. And now algorithms are learning from each other. They're crossover and mutating and creating an offspring that is even better than the parents. So that was actually the idea, and it's worked. And then all of this was managed by machine learning online. An online machine learning algorithm was managing the whole process of crossover and mutation and performance evaluation. And that was a very unique thing at the time. And guess what? We did the same thing at American Airlines, but without a machine learning algorithm. It was a much simpler mathematical technique.
Just for perspective, this was the early 90s?
No, this is 1997.
90s, so late 90s.
96, 97.
It's extraordinary. Well, you heard it there. Genetic algorithms. My guest, Wes Chaar, who's the Chief Data and Analytics Officer at Fyllo, and just give you a sense of, his journey in his career, but what the kinds of things that Fyllo are doing and the ambition that they have as it relates to applying data in service, or data assets, as you put it, in service of the business. So, Wes, as always, my friend, it's an absolute joy talking with you. I've learned about 42 things in the course of 30 minutes.
Well, I appreciate the opportunity to come and talk to you today, Clive.
It's always fun. Thanks so much, sir.
Thank you so much. You have a great day. Bye-bye. Thank you.
This podcast was brought to you by Screen Dragon. We break down barriers, make work flow, and unlock talent. Visit screendragon.com to see our software in action.